Okay, hi everyone. I hope you can hear me. I am Nur Husni. So I am going to show you how to use a sine bar to calculate angularity. Okay, so there are several ways to calculate angularity. So this is the sine bar method. Okay, we are using sine bar. So what is a sine bar? A sine bar is used in conjunction with a slip gauge block for a precise angular measurement. So it is for angular measurement, and a sine bar is used either to measure of an angle very accurate or surface locate any work to given angle. Sine bar are made of high chromium corrosion resistant steel and it is hardened, position ground and stabilized. Okay, so let's see to the next slide. So here we have several equipment that we use and several material also. Okay, so the first one, okay, let's see the first one. This is the first one. We are using parallel bar. So parallel bar, we're gonna use. We have many size. 10 mm, 12 mm, 8 mm, even 0.5 mm. We have, okay, to get a certain height. So later we will talk about that. And then we have this. This is a sine bar. So we are using this one. This 100 mm sine bar. Okay, so this 100 mm sine bar, and then we have a vernier caliper. So we use vernier caliper to calculate this, to calculate the parallel bar, and then we also have a dial gauge. Dial gauge is to check the dial gauge is to check the surface of the angularity, of course, and then we also have our material. So our material here, we have this triangle. Okay, so this triangle curved space. All right, this is 45 for 75 degree. Okay, so this is 75 degree. Okay, so we are going to the next slide. All right, so I'm gonna show you so how we use the sine bar. Okay, so right here we have the sine bar. So we have sine bar. We are going to use a trigonometry method. Okay, so this is a trigonometry. Okay, let's say this is our product like that. All right, so our product having 75 degree. Okay, so here we are going to have 75 degree also. Okay, so the length of this from here to here, we are having 100. Why 100? Because our sine bar is 100 mm, so that's why we get this 100. So the only one that we need to find is here, the height. We don't know what is the height, so we are using the sine. So the trigonometry method, so we have sine, or I always used to remember as so what this means is sine theta equal to O over H. Okay, sine theta equal to O over H. So it's equal to sine 75 equals to O, our O is H, over, so this one, okay, let me show you. This one is here, and the height is all the way up here. Okay, so this one H, and the other one is 100. Okay, so after we put the calculator on, we calculate this, we will get the height. So we get the height equal to 96.6. Okay, let me calculate that for a second. I need to check if it's correct. So sine 75 times 100. 96.6. Alright, so that's correct. So the height we get 96.6 mm. Okay, so we know already the height. Okay, so we are going to proceed to the next slide. Okay, here is the next slide. So the next slide. Okay, so what are we doing here now is to achieve. We are stacking the parallel bar to achieve the height that we want. So remember, the height that we want is 96.6. Okay, so back then we have draw a triangle. So this is the triangle. Let me redraw. This is our triangle. Remember? So this is 100 and this is 75 degree. Okay. The height that we want to achieve from here to here is 96.6. Okay, this is the height that we want to achieve. Okay, so let me erase this for a second and we proceed to the video. Alright, after we already did this triangle, we get the height and we put our product. Okay, so the reason we put the product, the reason we do this triangle is actually to match the granite table. Okay, okay, so let me use this. So we do this to match this. So these two is parallel. Okay, the granite table and our product is on a parallelism. Okay. Also, if we want to calculate the angularity, we must do it on a granite table. Okay. So this is how we measure. We are measuring using the dial caliper, dial gauge. Okay. So basically, what are we doing here? What are we doing here? We take the dial caliper and push it in a little. We don't put it only above, but we push it in a little. After that, we set the gauge. We set the gauge to 0. Yeah. So after that, we need to move front and back. So you can see our part is moving, so need to hold. So we are checking this front and back, front and back. So from the video, we see that the movement of the meter is not very far. That means it is very in a good tolerance lah. Means it is 75. Okay.
Okay dah, siap.
Alright. So I think that's all from my explanation and thank you.